So in this video I just wanted to show off some of the vector fields in Mathematica here. Right, so here's the two from the lecture video. So this first one here, this is -1, 1. Right, so you can see we still have these diagonal kind of northwest pointing arrows here. Right, and they're all the same size. Okay, here we have the vector field x comma y. And you can see, at the origin there's nothing, and then as we move further and further away from the origin, the vectors get bigger and bigger, or the arrows here get bigger and bigger. Right? And that's what we were kind of drawing on in the video. Right? So here's some more vector fields. So here's 2y comma 0. Right? So as y gets more and more positive, we see that these vectors are bigger and bigger. When y is 0, of course, everything's 0. And then when y is negative, again, the more negative it gets, the bigger it gets. But, of course, when y is positive, it points to the right. When y is negative, it points to the left. Since in those cases, the x components are positive up here and negative down there. The x component of the vector field, of course, which is 2y. And here's another interesting vector field. It's the vector field -y comma x. Right? So you get this interesting pattern of circles here. Hopefully you can see that. And you can actually trace out circles in this vector field here. And those curves that you can trace out are called integral curves. Right? So this is another interesting vector field here. And again, so if you pick a point, say, out here, or I guess right about here would be 1, 1. Right? So the vector would be -1, 1, which would point this way. Right? Here's a kind of more non-linear vector field, x squared comma y cubed. And again, towards the origin we have nothing. But as we move away from the origin, especially moving away in the y direction, the vertical directions, it gets bigger a lot faster. Okay? And we get this, because this is a non-linear thing here, we get this kind of interesting pattern of spreading out. Right? Now here's some 3D vector fields. So to start with, here's a simple one. This is x comma 0 comma 0. Right. So here we're looking at it where this is the x direction, this way. Right. So if we put it to the normal where we have x coming towards us, as we often draw things, you can see there's a bunch of arrows that are coming towards us and they're getting larger and larger. And then there's the ones in the back that, as x is getting more and more negative, they're pointing the opposite way and getting bigger and bigger. Right? You can see that here. They're kind of small in the middle and really big on the outside here. Alright. Then there's this vector field, y -xz. It has some interesting properties here. It kind of swirls around in the middle there. And again, this is why it's hard to draw 3D vector fields on a board, because they do really strange things like this. Right? You can kind of see the swirling if you look from above. Alright. And again, here you have that same y -x that we had up here, and that's why it's kind of swirling around. But of course the z is now causing it to do some other interesting things too. Right. Here's a constant vector field, like we had the vector field -1, 1 before in 2D. Here's 2, 1, -3. Gives you an idea of what a constant vector field in 3 dimensions looks like. All these looks like some kind of optical illusion thing here, the way it spins around. And here's a vector field, -x, -y, -z. This probably looks the closest to the like gravitational vector field, right? You see that the vectors are all pointing towards the center. The difference here is for a gravitational vector field, the closer two things are, the larger the vectors get, right? Because if two things are very, very far apart, then their gravity doesn't influence each other very much. But if they're close, it has huge influence, right? So this is kind of the inverse of that. Right? And here's another sort of nonlinear vector field, y, comma, xy, comma, z. And again, it just looks kind of like an interesting mess of things here, right? But even a vector field that looks as simple as this, there's no reason that, it has a kind of very, very simple pattern, right? So that was it for just showing off some of these vector fields. Hopefully you have an idea of what a vector field should look like. And again, there's many, many different vector fields. So, yeah. Okay.